So forensics is the process of examining and processing a hidden piece of information out of static data files. So there's a few pretty simple beginner introductory, whatever you call it, techniques, including file analysis, file carving, and steganography. Those are just really common ones to see, especially in the easy and medium challenges. So these will be the ones we're going over today. Commonly used tools, I'm almost always using a Parisolve if I'm doing a forensics challenge. It's extremely useful when it comes to steganography. Anything else, you'll probably want to be on Linux and use a variety of Linux commands. So those could include strings, hexdump, binwalk, etc. We'll go over a few of those today. So for the first section, we're going to do file analysis. So that's a forensics technique that involves analyzing a file to find hidden information generally. So I've got two PicoCTF challenges that I'm just going to run through as examples. So for this first one, it's called Glory of the Garden. It says this garden contains more than it seems. And then for the hint, it says, what is a hex editor? So what this looks like, it's pretty apparent that we're going to have to be going and doing some type of hex dump or just getting into that area of the file, the actual hex code behind it. So we can download this. I'm using Kali Linux. I just have a VirtualBox running. It's recommended that y'all do have some form of Linux distribution on your machine, especially when we're going through these competitions. All of the utilities make the a lot easier. I'm gonna drag the file over here, and then yeah, just on the desktop though. It won't let you do it if it's like in a folder or something like that. But yeah, we can go over this later. I'm gonna rename this. It was already downloaded on my main computer, so. Now I'm going to make a new folder that I can use to go through all these challenges. Just going to drag it in there. All right. Well, real quick, I can show y'all. If you open this file, we don't really see anything. It's just a garden, generally. So it's about the best we get out of that. But here it is. Look at this. The first thing you want to check generally when you are like downloading files and looking through them is like, is the file signature correct? You know, you have the extension at the end of it. It says JPEG. You want to make sure it's actually a JPEG image. So here you see that when I do file, that it's a JPEG image data. Next thing we can do is run strings, or actually let's do hex dump. And if you haven't used hex dump yet, I think we touched on this maybe the first couple meetings. Essentially just extract all of the hex data from that file. So look at the help. We have a bunch of different information here, but what we want is to see if there's information besides just the hex code. So what we can do is use the canonical flag -C, and what that's going to do is it's going to give us that actual hex code, but it's also going to give us the ASCII code. So we do hex dump -C, and then that file was garden.jpg. This is a huge file, obviously. I can let this run. And then down here, we're going to see that we have some ASCII code that says here is a flag, and then it gives us the flag. So again, this challenge is pretty straightforward. You know, we just looked at the hint, did what the hint told us, basically. I know that was a lot to watch all of that go down, but that's something you just got to get used to seeing. And usually none of the information is useful, like a lot of that. But we want to be able to like copy and paste that flag. Say we want to submit it. That's not going to give us the flag directly. We're going to get a bunch of the hex code in there too. So when we see something like this, we can just run strings, and then that prints out all of the strings that are present within the file. And then it gives it to us real nice right here. Just where are we? We lost the presentation. There we go. Okay. And then the next challenge we're going to go to is called Secret of the Polyglot. It says the network operations center of your local institution picked up a suspicious file they're getting conflicting information on what type of file it is. They brought you in as an external expert to examine the file. Can you extract all the information from this strange file? So notice that they said they're getting conflicting information on what type of file this is. As I mentioned a couple minutes ago, a lot of the times that you're downloading files, you want to look and make sure that the actual file signature matches the extension on it. A lot of times in these challenges, you'll get some file with maybe the signature itself needs to be fixed. Maybe there's a missing bit in it, or you just have it completely misnamed when it comes to the extension. So the hint says the problem can be solved by just opening the file in different ways. I'm going to download this real quick. So it looks like it's a PDF file. I'm going to drag this over. Come on. And then, well, actually, first we can open it up, and it's titled flag 2 of 2, which suggests that what we see right here is just the second part of the flag. So we need to be able to figure out where the first half of that flag is. So let's employ a little bit of the techniques we've been talking about. I'm going to do file flag 2 of 2 final, and we see that it contains PNG image data. That's what the signature is telling the interpreter when it runs file. The command, the signature is a PNG file's signature, not a PDF file. I'm not sure exactly how they made this challenge. It's very cool to me. I haven't looked into actually creating this side of the forensics challenges, but what we can do here is change that file extension to PNG and give that a try. Try opening that up, see if that does anything for us. So we just use the move command, which allows us to rename but keep the same file data. Now I can open that up and take a look at it now. And there we go. That is the first half of the flag. So again, like I was saying, it's a pretty cool freaking challenge. Being able to have that display as a PDF and also a PNG, just depending on changing only the file ending. It's very cool to me. But putting that together would give us like the full flag. Actually, there we go. File carving is going to be the next kind of subcategory of forensics that we're going to look into. And it's a forensics technique that involves identifying a file embedded within another file and extracting it. So common tools for this are binwalk and scalpel. I always use binwalk. I've never really used scalpel, but I think there's some use cases where you might try that one. But we can go ahead and look at this challenge. And it's called Hide Me. It says every file gets a flag. The SOC analyst saw one image been sent back and forth between two people. They decided to investigate and found out that there was more than what meets the eye here. And for this challenge, we don't get any hints, but we can go ahead and download. Click here, we can download that flag, and let's take a look at it. Usually the drag and drop works pretty quick. Let's give me a thing. Okay, there we go. Let's see. I'm going to drop it in that folder so I can go ahead and take a look at it. Maybe I'm not. Terminal here. All right, CLS. We've got flag. I'm going to rename that. Get that file. We see that it's a PNG image data file. That matches the extension. That's all good. I'm going to look at a Parasolve. Actually, no, we can save that for the steganography. For this, I'll just go through it how you might typically if you were just using Linux. So I'm going to run strings, which that's going to give us all of the strings that are within that file. And we see down here, these look like they're referencing other files. So we see secret being a directory, and then secret/flag.png being a directory. So it's very interesting to see it being part of one file. having some directory that contains another file. But what we can do with that is we can actually extract that data out of it and then take a look at that data itself. So we're going to use binwalk. And then again, if you haven't used binwalk before, this is just another Linux tool that allows you to go through and extract or perform file carving itself. And then if we look up here in the help, we see the -e flag is going to be extract, which will automatically extract known file types. So when it's parsing this file, going through it, if it sees or finds any files that it recognizes the file type for, it's going to automatically extract that and put that out of the file. So we can do that. We're going to do binwalk-e, and then we have flag1.png. And so that shows us here that we've got, this is all of that data that was included within flag1.png. We have a PNG image, some zlib compressed data, some archive data. This is a very important one here. That's that directory secret that we saw before. And then here we've got zip archive data that we see secret/flag.png being part of. And that's the end of that zip archive. So now we can do ls, and we've got here flag1.png.extracted. Now it looks like a file, but that's actually a folder. It being blue shows that. We're going to cd into that. And now we've got 4 pieces of information here. I'm going to ignore all of this because from everything we've seen so far, we're looking for this secret directory, and then secret should have flag.png within it. We're going to cd into that. And there we go. We have flag.png in there. I'm going to now open that up. Take a look at that. And we have the flag as part of that picture. It's really interesting. I mean, this was a zipped file or a zipped directory that was embedded within the actual original image that we have. That's something you're going to see a little bit, especially in these forensics challenges. So you're going to be using binwalk a fair amount. So honestly, it's typically just that standard command binwalk-e, and then whatever you're trying to extract. So now we can go into the third and final category for this introduction to forensics. We have steganography. This is personally one of my favorite categories. I think it's very, very cool. It's very similar to file carving in general, but it is it's steganographic images are digital images that have hidden information within it without noticeably changing the visual appearance itself. Yeah, what's up?
So, although steganography is technically forensics, NCL categorizes it as cryptography, as like many other CTFs.
Right.
So, a lot of times you'll see steganography appear in like the cryptography kind of categories, but it is actually forensics. But yes, steganography is also considered the most hated field for some reason. I don't know why, but people don't like this field for some reason. Which, I mean, fair enough once you get to like some of your more complex stuff. But for the more easy stuff, this is a pretty fun category, just like having like an image and get like super data with it.
Yeah. One of the cool things about it is how steganography actually works when it comes to images is by leveraging least significant bit changes. So say you have some hidden information you're trying to put within an image. If you're familiar with hex codes when it comes to like colors, like color codes, you have FFF, which is like 6 Fs. That's going to be white. But subtracting 1 by from the decimal number, I guess, representation of that is still going to look just like white. Like it's going to be a little bit different. You're just changing the least significant bit, but it's still going to look like perfect white. So that is what steganography pretty much leverages to be able to hide information. Because when you open that file and all of these colors have been changed so slightly, the human eye can't even recognize that. But there is information hidden in it. We've got 2 challenges that we're going to look at. Some common tools that you're going to be using for steganography are zsteg, steghide, exiftool, and binwalk, which we just looked at. One of the things that is really useful that we leverage a lot is solve, like I mentioned before, and that runs all of these tools for you when you pass an image file. It's the website you go to, upload that image, it's going to run all of these. It makes your job a lot easier. So this first challenge is called information. And it says files can always be changed in a secret way. Can you find the flag? File is cat.jpg and download that. It says look at the details of the file and make sure to submit the flag. That's the standard format. I'm going to use a Parasolve for this. No ad blocker. And kind of like all right, let's quiet down about that. Kind of like the whole theme of this has been things hidden within other things, per se, so to speak. So we look at this image, just a cat like sitting on a laptop. There's not much significance to it. I mean, we can zoom into this text, but that doesn't really help us at all. It's kind of just something going on in the terminal. But we see all of these like different color superimposition, all these changes. This is rarely useful.
This is not useful for cryptography and like cybersecurity in general. This is very common with video games. They usually have Easter eggs within their images. So if you drop it here, you can sometimes find information.
That's a good point. Zstag found nothing. Stag hide could not extract any data. Outguess, not much help. But if we look at exif_tool, it's going to give us all of the exif data on that file. Exif data is very, very common, and it's attached to almost every picture you've ever taken. And it is attached to it. That could be a lot of different things. You know, there were security concerns about like your location being attached, where you took the picture, or the timestamp when you took it. That's a big thing. That has just always been a thing. It's always been a thing in pictures you take. So we see, if we scroll through this, we see the copyright notice exif data is called PicoCTF. Doesn't really do much for us. But if we look at this license, I mean, this is not a standard like name for a license. This doesn't really mean anything. This is just a bunch of strings or a bunch of characters that you might be guessing could be some type of encoding like base64. We can try that. But real quick, let's look through the rest of this. Yeah, not much left. Binwalk returned nothing except for the file itself. So we're going to go with this and give this a try because that's really the only information we're seeing so far. So I'm going to do base64, decode. CyberChef. Yeah, CyberChef is one of the big tools that we are going to be using like in all of the competitions whenever you have some type of cryptography. So I'm going to put that base64. Oh, dude, I have never seen that. That's really, really useful. Yeah, so sometimes when you put information into CyberChef, you'll see a magic wand that appears that tells you, it's kind of like automatically detecting that is base64. It tells you what it translates to, or it decrypts. Does it automatically put? Yeah, that's friggin' awesome. Okay, so generally using CyberChef, I'm going to just show it real quick. All of these different, there's like a just ton of different operations that you can do. The one we're looking for is from base64. Just drag that in. Or click that magic wand and automatically appears if that wand does come up.
The magic wand appears like 1% of the time. It's not super reliable. But it's like base64, it'll always appear. And with like images, there's like just like a PNG or something. Like it'll render images for you and stuff with the magic wand. But it's not like a detector like a decode or like other detectors things.
So there we have our flag and the output. We can just copy that over and have that solved. I'm going to look at the second challenge here, which is Stego. I think I pulled this up when we had that one intro day when I was sharing PicoCTF trying to show you all how to use the platform. But we can just run through it. It says, we know the end sequence of the message will be $stego. So let's just download this image. And then sometimes in challenges, it'd be very nice if this was always the case, but Pico, being a very beginner-friendly kind of platform, gives us some tags for challenges. It shows here steganography. That's one way you can know that's what we're doing. A lot of times you get an image, you're going to know that steganography, or at least give that a try anyway. So I'm going to go back over to Parasolve. Go back out of it. Could really use that.
Yeah.
Okay. Do this new PNG file. I'm gonna submit that and then wait for this to process. Sometimes it's very quick, sometimes it takes a bit. Depends on your machine.
Yeah. If it's not like a new file upload, like if someone else uploaded before, it actually stores it on the server with the hash. You can see that like at the URL is like verysoft.com site. That's like static URL. You can copy paste and share it. It's like when you submit the file, it's gonna compute the hash, and if the hash exists in this database, it already has it stored, so it won't actually process anything.
It's good they did that. It's really freaking useful. Um, so actually, it's just right up here at the top, and the RGB, LSB, XY information. Yeah, we have our flag right here. Um, One of the things that that hint is trying to direct us towards is we know the end sequence of the message will be stego. So say that you weren't using a Parisolve, which again we really recommend at least trying. That's kind of telling you to use the grep command on Linux if you're familiar with it. If you're not, it is just allowing you to search through files, directories, even if you pipe things. So you would search with grep for that keyword that it's giving you. But anyway, we get the flag here.